computing technology and algorithm developments. So
Absolutely.
basically,
Yep.
this is nothing but kind of a automation or which is naturally evolving always, and we just gave a new name to this as AI. For example, any new application which can do such automation activity, now I look at it AI as yet another application. So what is different in AI than that of any other so-called automation which is intelligently built in terms of intelligence in the algorithm? So how is
Yeah.
how is this differentiating from yet another app or yet another application of software development algorithms and human intelligence when the way we put it into automating the stuff?
Yeah. So end of the day, an AI app and a non-AI app, right? App wise, both are same. The way code is written, the way algorithms are written, the way it is deployed, the way it is running, all those aspects are same, right? It may be, AI models might be written in Python. The standard application code might be written in Java or something, but net they're all helping us to automate something. That is a common thing, right, between AI and non-AI. Now, why AI is different, or where AI is, when you say AI, right, artificial intelligence, the whole word actually means that you're making the machines intelligent. Intelligent in what way? In the way that humans would do, right? Why are we doing this entire thing? Because I don't want, let's say, every day morning I have to come, get the list of all the items and write it somewhere. Let's say that is a very simple task that I need to do, right? It's a very repetitive task. So why can't I build a mechanism in which there is an agent or somebody who will come and do that work for me, right? So can I, as a human being, offload some of these repeatable mundane tasks, validating pictures, validating images, extracting captions from images, extracting entities from a contract document? These are all very repetitive patterns that we see. Now, for each of these repetitive patterns, can I build an AI model which will think like a human and do, right? So if you look at, uh, so what can humans do? Humans can see. Humans can, in fact, 2 days back I was going through a TED talk, and in the TED talk, the speaker actually mentions his 6-year-old niece comes and asks what is AI, right? And it took some time for him to kind of get down to her level to make her understand what is AI. But net, if a human can see, if a human can read, if a human can think, if a human can reason, and if a human can act, these are all cognitive capabilities. Now if you want machines to do that, you need to build those capabilities in the form of models is the brain behind making this entire thing to work. So now we are making these machines behave like humans. That is the only difference. In terms of application, an AI based chatbot versus a normal chatbot is the same. An AI based fraud detection algorithm and a normal fraud detection algorithm is the same. But in a normal fraud detection algorithm, you will have rules, right? But how to process those rules is done by a brain. And that brain is nothing but the AI. So, AI, how it is different, how it is going to bring a difference to humankind is because of the fact that it will more or less start thinking like humans, and a computer will do that for you what a machine would do, right? Otherwise, code deployment, everything is all the same. A UI interface is same, but now UI interfaces are evolving because nobody wants to type, right? People only want to speak and get the job done, right? So that's where we headed.
Right, just a continuation question then. For all these developments, training the model is still an effort. So that means the correction or corrective actions to be taken to take it to the next level still exists. So it is not really an artificial intelligent algorithm which, like we are building, that human being is infusing that intelligence still. So that effort from human being is still going into that. Then how it is different than yet another regular algorithm?
Yet it's yet another regular algorithm. Just the fact that, and there's no self-learning, right? Like humans have this capability of self-learning. Now, let's say I saw somebody playing a guitar. Over a period of time, I learn how to play a guitar. I do self-learn, right? Nobody has to train me. I can train myself. But here, the humans are involved in building these models. Okay, so let's say, for example, the base models which were built only said, can I identify a hat here? Is this an image? Is there a danger? Very basic elements only were being built, right? Over a period of time, humans intervened, and then they said, if this is this. So typically, the way machine learning happens is you have labeled data sets. So a human sits, creates those labeled data sets. So if you take, let's say, alphabets, I want to do OCR, right? If you say alphabets, I can write A like this also. I can write A in a cursive manner. I can write A in any, in multiple variations, right? If human being sees 10 different kinds of A's, human being can understand. But if you want the machine to understand 10 or 20 different ways of writing A, first you need to train that machine saying that this is A, this is also A, this is also A, and this is also A. So you're having labeled data sets. You will iteratively process and give those labeled data sets to the model. The model then learns and learns and learns, and next time when a new A comes, the model then identifies, okay, this is closest to A, so now I'm going to classify this as A. So that intelligence we are only building, machines are not learning. It is, and as you rightly pointed out, the entire crux of these models, any kind of models that you take, is in the training process. The algorithms, if you see, look at the code, right, it is not like humongous lines of code. In fact, if you look at custom apps that we build, there are so many tens of thousands of lines of code to have an Amazon app built. Okay, to have a, Mintra app or an Amazon app that you are building today, you have tens of thousands of lines of code. In an AI model, you don't have so many lines of code because the model is there. What you're only training the model to do is to learn the weights. Is it an A? Is it a B? Is it an A? Is it a B? Same question is asked 1,000 times. Only then the model learns once. It's like that. So it's a totally iterative, data dependent, data heavy approach. The data creation, cleansing, cleaning, labeling, and model training is consuming maximum effort in the model space. It's not creation of new models. uh, and historically, even if when computer science engineers have and PhD graduates who have built newer models, they would have taken 2-3 years to identify one best model, how it works, and it's only hit and trial. Try this, doesn't work, try another architecture, doesn't work, try another architecture, doesn't work, try another. That's it. That's about it, what they have done. So the entire effort in any AI model goes mostly in your training phase and your data set creation phase.
Thanks, man. That makes sense.
Yeah, we will take one last question from SR Singh.
Ma'am, when you're designing these models, implementing them, or deploying them, especially to internet-facing applications, is there some kind of a logical boundary built into it so that it doesn't, go into that paperclip apocalypse kind of a situation?
No.
Is this built in from beginning, or you restrict the training to a certain level only and don't allow it to learn further?
Yeah, so you're talking about two things here. One is the training phase, the other is the inferencing phase, right? When you say training phase, let's say I'm training on the alphabet data set that I was talking about, right? To keep it simple. Now I have gathered all the alphabet data sets, I've trained the model, I've achieved a certain level of accuracy, I've minimized all the losses, right, in the learning process, and I've achieved a certain level of accuracy. Let's say I have 80-85% accuracy. Now the model is ready. Now what I do is I deploy the model somewhere, right? And the internet facing application that you're talking about, let's say it is doing OCR, that application actually uses the deployed model, not the model which is being trained. So two different, very distinct set of models are there. One set where you're training and building these models. Once that model matures, then you take that model architecture, you deploy it somewhere. There, the inferencing happens, and that inferencing point is where your internet-facing applications actually hit that endpoint, not the model training endpoint. But let's say you discover a use case there saying that okay, this particular use case did not work, then you will train the model separately, build that model on a newer data set. When you see, why will a model not work? Only because of the fact that it doesn't have the right data set. That's it. If you give it the right data set and if you give it the right label, it's only a question of putting in its memory that this is also an A. That's all, right?
So ma'am, what you basically see is that you are deploying a snapshot of the trained
Yes,
AI, but you do not allow it to generalize any further.
correct. Yes.
Understood. Understood.
Yeah, there is one observation by Sunil. So that means the hardware requirement in terms of storage, processing speed, and internet speeds, etc., are huge and must.
Huge, very huge, very huge. In fact, to train these models on some GPU based hardware, you would need about 1400 GB of RAM to run. Unlike any machines that we have seen in our personal lives, right? 80 to 1400 GB of RAM is needed to train some of these large language models, and that is why the people who are providing these models, people like Microsoft, Google, and others who are providing these models, they're able to provide because of the kind of hardware that they have, right? Otherwise, you and me also could sit and build and train these models, but these are very, very limited hardware. Hardware is still not come. In fact, if you look at, if you say I want to build a custom model and I want 10 GPUs, you might not even find it so easily, right? So very heavy duty infrastructure. You can't even imagine the kind of innovation that has gone into, right from chip to hardware accelerator to coolant to the optical fiber cables in the data centers, to the way the data centers are connected, to the way coolants are managed, to the way power is managed, to the way storage is managed. It is outstanding. It is outstanding. It is unbelievable. And it is because of that hardware innovation today we are seeing models left, right, and center. Everybody is using Chat GPT, and Chat GPT pretty much solves anything that you ask, most of the cases, right? So you're absolutely right, but nobody knows, nobody can imagine that this is the extent.
Thank you. I don't see any other questions. Any other questions from the participants? Else we'll have to let Divya ma'am go. She's got a very busy schedule today.
It was an absolute pleasure. I think the questions were really, thought provoking and insightful. So happy to have you here. Please do come and visit Microsoft Technology Center. In case you're interested, you can reach out to me. My coordinates, I think Jeet has already, floated in the circular. You can connect with me offline as well, and happy to kind of, take any of your questions, or happy to get connected with you later as well.
Yeah, ma'am, just one last question. Adarsh is a faculty with IIM Bangalore. He's got a question. Adarsh, please go ahead quickly.
Yeah.
No questions from my side. It's actually a thumbs up.
Okay.
Session has gone well.
All right. All
Yeah.
right. Okay. So thank you all for joining today's session on generative AI. We had very good numbers, ma'am. 45 across both the platforms, YouTube as well as GeoMeet. Special thanks to Divya ma'am for her insightful presentation, and really appreciate you joining us in spite of your busy schedule. Finally, thank all the participants for your engagement and questions. Thank you all. Thank you so much.
Thank you very much, ma'am.
Yeah. Have a good rest of the day. Bye.
Thank you. Thank you, ma'am.
Thank you so much, ma'am.
Bye.
Thank you so much, ma'am.